This is a basic format of a for loop, and we start from this. This is the basic format, and every part is differentiated by a semicolon, as you can already see here. And first, this is the initialization. We just initialize variable outside of the for loop, and here we can use it as for initializer. And this is a place where we start, where we want to start our program. We want our program to get started from. So here, there's a condition. The condition is the control. When control goes to conditions, we just make sure that the condition is matched as our initialization. That is this initialization value matching with our condition or not? If it matches, it goes to the statements and executes everything inside this for loops, within these two curly brackets. We just execute each and every part of the statements available here, and then after this, it'll go here and make some operations with the variable. This means initialized variable, you'll make some operations with that variable. This means addition, subtraction, multiplication, division, or any kind of operation with it. So after it does, it's updated and its initialization value is reassigned with these already operated values, and initialization will be updated and the condition will be checked again. If the initialized values which is updated after this, does this match this condition now? Yes. If it matches, it goes the same way and executes the statements here and goes here and again as operation with this. After this operation happens, it comes here and reassigns the value, and then condition checking occurs here, and here we execute our statements. And then after that, let's see if this condition didn't match, then we are forced to jump out of this loop. After that, if this condition doesn't match, it'll go out of the loop and start executing other programs available out of this for loop. So if the condition didn't match, it'll go outside. If the condition matches, it'll start executing again and again until it's false. So it will be executing the same thing time and again until it's false once. It will do the same thing all over again and again. But if it's false once, it'll break out of loop and get out after this. Let's make it easier with some pseudocode. Here we start from initialization. Let's say we are initializing x value with 0, and then what happens, as I already said, condition checking happens here. After that, if x equals to 0, we check the condition, and we set x to 0, and we had a condition here. If x is less than 2, as x has value of 0, and is that 0 less than 2? Yes, it's obviously less than 2. 0 is obviously less than 2. And then what happens is, yes, if it's true, then it'll start execute the statements there. As I've already said, the condition matches and the statements are executed. So the same thing happened here. We're executing the available statements, and this is what it did. We printed add in our console. Next what happened is we did some operations. X equals to x plus 1. We just incremented our initialized variable with 1 as an operation. So what happened is x equals x plus 1 is 0. X equals to 0 plus 1. So next, here value after operation. This is a reassigned value. Here it was 0, and now here it is 1. After its assignment, after a operation, its value is 1 after update. So what happens here? Again, the condition is checked. As I already said, after reassignment, it will be checked with the condition if it matches or not. And the same thing is happening here. We're checking the condition. It's 1 less than 2, because we're already 0 plus 1, it's 1. So 1 is a new variable. Is 1 less than 2? Yes, it's obviously less than 2. So if it's true, then the control will go again and execute the same thing here. Execute the statement available inside that for loop block. Then after that, again, it goes and increments, decrements, or any kind of operations will happen for the for loop. Then after this, x goes to x plus 1. This means 1 will be 1 plus 1. This will be 2. So x value will be 2 after this operations. So x value will be reassigned to the 2. So here was 0, here's 1, and plus 1, 2. Okay, after operation, this happens. And what happens is condition is checked. Is 2 is less than 2? It's obviously not, because 2 is equals to 2, but not never less than 2. So after this, if it's false, it will jump out of the loop and start executing other states. Okay, if you didn't understand from our previous lectures, and let me make you understand with some real world cases, or you could say a real world example. It's not a real world, but actually it will help you to learn to grab some concepts of C programming for loop. So here, let's say we're initializing an integer value x, and we are using it here. And this is how the program works. We're initializing a variable, we are putting it inside our for loop. This has a first argument, this is an initializer. So actually we initialize from 0. We want to start our program from 0. So then what happens? This is a condition. So condition is if x equals to less than 4. If it's less than 4, right? It's not more than this. If x is less than 4, what it's saying, it looks x actually less than 4 because 0 is less than 4. So this will print %d is less than 4, \n, x. This means %d indicates an integer variable. So x has its own value, initialized value 0. So 0 is less than 4, and \n as a new line character. As a new line and a value of x. This means 0 is less than 4. It will be printed once and go. The control will go here at x++, and this will be incremented. X++ is an incrementing value. This means this equals to x plus 1, the same as x++. So in order to lower the size of code, we're doing this. So before this, x has value of 0. After x++, x will be having a value of 1. This means 0 plus 1, it's 1. So 1 is again sent here for checking the condition. 1 is obviously less than 4, yeah, and it will be executed, and the new value of x will be 1. So 1 is less than 4 \n, and again, so again this control will go here and increments or has any kind of operation with it. So x++ is 1 plus 1 is 2, and 2 will again go here and get reassigned, and 2 x will be 2. Then printf, it will start, no, x will be 2, and then it will go check the condition. Yes, the condition match, because 2 is less than 4, so 2 is less than 4. And here we write %d as a 2 is less than 4, because x has a value of 2 after this increment. So the control will go here and print this, execute this statement inside this, and then it'll go outside. Not outside, but here. This is called x++ increment. So x add value of 2, and now this will be 2 plus 1, 3. 3 will go here, and x will be reassigned to x equals to 3. So 3 will go here, and condition will be checked. 3 is obviously less than 4, so it will be printed again. And 3 is less than 4 because x has a value of 3, so 3 is less than 4. And same thing happens again, and x will be incremented. After incrementation, x value will be 3 plus 1, 4. But 4 will go here and get reassigned, and also will come here for checking the condition. Yeah, 4 is less than 4. It's not possible because 4 is equals to 4, but it's not less than 4. So what happens? Control will not be able to go here because our statement already went false. So this condition went false. So if it's true, it will again loop through this part only. But if it's false, it will break out of the loop, jump out of the loop, and start executing other statements outside of our for loop curly braces. So it will leave these two curly braces and jump out of it and start from here. This is our program. What happened is %d is equals to 4, and this will be printed. This means after this incrementation, the value of x will be 4 because x is 4 and 4 is less than 4 didn't match, so x value will be 4. So it will go outside this because it is incremented, it is declared outside of the for loop. We can use it here. So %d is equal to %d. This will be 4 is equals to 4. Let's see this in a C programming code. So we're copying it and pasting it here. A Sololearn code playground. And one thing, make sure of this color. If it didn't show some color, you may need to know that these are not the two inverted commas. So what we need to do is replace it because it came because of the font of that Google slide. I mean, a Microsoft presentation PowerPoint, and this I should be small. Let's run it. Yes, the same thing happened. Everything we wanted to have. So here it started from initializing x equals to 0, x is less than 4 as its condition matched, and it printed 0 is less than 4 because x has a value of 0. So see here it happened same thing, and then again if it's incremented, after incremented it went again here and x is incremented, and after that x will be reassigned and came here. After that the control came here and check the condition. 1 is less than 4, then 1 is less than 4 is printed like this here. And because of this new line, it came after a new line because I added the backslash n character, and it goes until the condition is false, because when the condition will be false in case of this incrementation, when x equals to 3 it won't be false because 3 is obviously less than 4, so it will be executed. But when it is 4, then 4 will not be less than 4, so it will be false, and it will break out of the loop and start executing the statement from other loop. I mean out of the loop. So this is what happens. 4 is equals to 4. After that it went out of the loop and started executing this one part. I hope you understood. So let's see. You may know that the for loop is not only for incrementation. Now we are starting our C programming for loop in our decrement operator. So here what happens is, as usual, we declare our integer variable outside and we use it inside as a initializer as 4, but this time note that we didn't start our program from 0. We started our program from 4. So what happens is we'll start from 4 and we'll go up to 1 because we decremented it. Because if we decremented it, it'll go downhill, but if we incremented it, it'll go uphill. But we need to know something more about it. We'll know about it later. But what happens is we started our initializing variable as a 4, and x will be, so we will be stopping our loop at 1. So what happens is x equals to 4. Yes, now condition is checked. 4 is more than 1. Yes, obviously 4 is already more than 1. So what happens is we print % is more than 1. This means % is 4 in this case. So initialize variable % is 4. 4 is more than 1. Okay, and new line will be put there, and what happens is control will go next here and decrements the operator, decrements the initialized variable. The 4 is initialized variable, so minus minus will be 4 minus 1 is equals to the same as saying as 4 minus 1. So 4 minus 1, 3. The 3 value will again be reassigned as x here, and what happens, x will be 3. So is x more than 1? Yeah, it's obviously 3 is more than 1, and what happens here, so 3 is more than 1. As I've already said, this will be reassigning it. X has 3, so 3 is more than 1. Okay, and what happens here, after this the control will go here and start decrementing it again. 3 minus 1, 2. Okay, x will be 2, and 2 is obviously more than 1, so what happens, 2 is more than 1, and again then another decrementation. 2 minus 1, 3, and 3 will, okay, 2 minus 1, 1, and the 1 will be sent here again, and x will be having a value of 1, and again now this time we're checking the condition if it's true or not. 1 is less than 1. This is obviously not true because 1 is equals to 1. So if our 1 is equals to 1, what happens, as I already said, it's not true, If it's false, it will break out of these two curly braces of a for loop and start here. And what happens? It will print some dashes, and after that a new line, and another one will be the percentage d is equals to 1. This means we had our variable value 1, x variable value is 1 here because we decremented it here. After this, the final value will be 1, and what happens? The printf percentage d is equals to 1, 1 x equals to 1, because here we decrease our value from 4 to 1. So when it's 2, it's fine, but when it's 1, it'll break out of this, and it will not try to decrement it, because it won't even execute this part too. Because after it gets false, after it is false, it will break out of this and start printing out of the loop like this. So let's see the same thing in C programming. So we copy and paste it here. Is everything alright here? We need to check it here. So here is some kind of bullet point, right? Or something. It may not bother, right? So let's get starting running it. Okay, there's some error. So you need to know how to debug these kind of error. These were causing an error here. So now run it. Yeah, that's it. That's how we learn our decrementing for loop. So we need a good formatting, because formatting is important for readability. So this is it, and same thing into the running. And this, as I've already said, starts from 4 and goes to 1. 4 is more than 1, 3 is more than 1, 2 is more than 1, 1 is equals to 1. After breaking this loop, we just added a number of dashes here because we want to show something. We already broke out of the loop. So this is an example, and I hope it's clear, because here what we did is started from 4 and printed it, decremented it, then went to 3, printed it, decremented it, went to 2, printed it, 1, and broke out of it, and printed the outside. This is it. This is a recap. Okay, let's see if we are not actually doing this. There is another loop, this same kind of loop, but it's a different version of it. It's an infinity loop. What happens is an infinity loop. Here, when we initialize our variable, we done everything correctly, but one thing is what we did was one thing, just mistake. Instead of decrementing it, we just incremented it, because when we start from 4 and we're checking the condition, we are actually gradually decrementing our variable from 4 to 3, 2, 4 to 3, and 3 to 2, 2 to 1, and then we just broke out of this loop. But as I've already told you before, this will execute everything until it's false. So I'm sorry. This will execute everything until and unless our condition is false. This means 4 is more than 1, right? So 4 is obviously more than 1, but if we are incrementing it, let me make it clear. But here we started from 4, and 4 is obviously more than 1, and what happened is 4 is more than 1, and what we did was we incremented actually instead of decrementing, because we cannot reach lower value from higher value just by incrementing it. Because if we increment 4 from 1, if we increment 4, what will happen? It will be 5, 6, 7, 8, 9, 10, but it will not reach 1. But if we decrement it 4, then it will reach to 4 after some iterations, after some repetitions of this loop, because we already made it, but this time we incremented it. So what happens is this will start doing everything. What happens here? This will start from here, go here, 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 and same thing happens again and again, because it will become infinitely positive. But is it just 1? And it's actually starting from 4, so it will not even stop because it will just start from here, here, and here, and here, and there's no chance of breaking out of this loop because when it's a higher number and we want to reach lower number, it's not possible by adding it, just by adding it. So just by incrementing it to be specific, we are incrementing it, so it's not possible to reach a lower value from a higher value just by incrementing it. Or then we have another case, so where we starting from 0 and we want to get to 9, but we are decrementing it. So this is less than. So what happens? This is actually go downhill. This program will go downhill, but we want uphill. This is 9 and 0 is already the lesser than 9, and what happens? You'll get even lesser. This will be 0 is less than 9, and if it's true, it'll execute this statement, and then after what happens? X minus minus is 0 minus 1. This means 0 minus 1, that is minus 1. So minus 1 is less than 9. Yes, minus 1 is less than 9. Again, minus 1 minus 1. This will be minus 2. Minus 2 is less than 9. Yes, minus 2 is less than 9. And same thing happens again and again and again until the minus infinity. This is what we call an infinity loop. Let's see this code in action. So we copy it, paste it here. Formatting is necessary for readability. I've already told you. What we do is some tabs, okay, and a little bit of correction because we don't want capital letters in our program. So what happens? Okay, there's some error here. We didn't fix this. So what does it say? Declare the wash here. Oh, we declared it twice. Okay, no worries. Now let's see. Still the error persists. The program %3OL. Oh, again the same error. This is, we need to check these because if the styling format is mistake, the whole code will give you some error because of this. What we had AL body and it's stylized type of the inverted comma, but it didn't accept here. So anyways, we fixed it. What happened? As I already told, 0 is less than 9. Okay, let's see. So everything is true and true and true. There's no any false. If it was false, it would break out of the loop and stop. But what happened? 0 is less than 9, and again minus 1 less than 9, minus 2 less than 9, 4, 10, 15, 100, everything here, and it went until the execution timeout. But in your actual code environment, this will not happen because it had a limited space. The online C compiler for Sololearn had a limited space, but your code compiler will run until it's in infinity. This means it will run entirely, even crashing it or happening anything, I don't know, but it'll run a lot of times, more than this. Not only 107, it'll go a lot far away if you run it in your code editor. So this is what it is. So we wanted to get to 9 from 0 by deducting it. It will go to minus 9, but minus 9 is obviously less than 9, so mathematically it's incorrect. So that's why this is a infinity loop.